Hello everyone, welcome to my chemistry channel B.L.DASH short and sweet in chemistry. Now I am going to explain the chapter coordination compound for class 12 according to CBSE syllabus. Now my topic is just solvate isomerism. Solvate isomerism, that is a part of structural isomerism, and now this is the part 6e. And here what is structural isomerism? Structural isomerism means here the arrangement of atoms are different in a structure. That means same molecular formula but arrangement of atoms in a structure is different. That means here you can say that is structural isomerism. Structural isomerisms are four types. One is linkage isomerism, coordination isomerism, ionization isomerism, and the last one solvate isomerism. Solvate, solvation, solvent. That word comes, that means it is one type of solvent you use. What is that solvent? That is water molecule. Water molecule can use as a ligand, can use as a solvent, but how it will use in a coordination compound. Water molecule can remain inside and outer side coordination sphere. Water molecule inside also you can put, outer side also you can put, but what is the name when inside, what is the name in outer side? Inside the coordination sphere, that is called as ligand. Water molecule behaves as ligand. That means here we will put water molecule as a ligand when it is inside the coordination sphere. That is called aqua. It is a neutral molecule. It is called aqua. Now outer side coordination sphere, it is free. It is free, it acts as a solvent molecule. It acts as a solvent molecule, that means it is free in nature. That is why on heating it can evaporate, water molecule that can disappear. That means here outer side the sphere, that is free. Inside the coordination sphere it is not free, it acts as ligand which is bounded to the central metal atom. Now we will see example. Already you know the water molecules act as a solvent when it is present outside the coordination sphere, and inside the coordination sphere that acts as a ligand. Now see this example, six water molecules are surrounded, bounded to the central metal chromium, and whose oxidation number is 3. Now you can see this is hexa-aqua, chromium 3 chloride. Hexa-aqua chromium 3 chloride, there is no water molecule outside the sphere. That is why here it is called anhydrous. The color is violet color. Hexa-aqua chromium 3 chloride anhydrous. Then its isomer, that what to do? Here one chloride ion you take to here as a ligand inside the coordination sphere, and from coordination sphere you take one water molecule to outside the coordination sphere. That means now if you take water molecule from inside to outside, it will behave as a solvent, not behave as a ligand. But when chloride ion you take from outside to inside, now here it will act as a ligand. So now see here one chloride ion comes to here and inside the coordination sphere, that is called chlorido. And now water molecule 1 decreases because the one goes to outside, then penta-aqua, chlorido, chromium 3 chloride. Again see penta-aqua, chlorido, chromium 3 chloride. Now you can see this is the charge of the complex ion +2 and chloride ion, that is -2, cancel because chloride ion you know -1. Another isomer, if you see here again you take water molecule from penta 5 times what is present inside the coordination sphere, you take from here to inside the sphere to outside sphere, and that is what is the name? Penta-aqua. Now it is penta-aqua chlorido, chromium 3 chloride, and that is called monohydrate, and here color is blue green, and first what is anhydrous, the color is violet color. Other isomer, if you take another water molecule as a ligand, but when it takes out to outside the sphere, it behaves as a solvent. So how many solvent molecule in outer side here? 2 water molecule acts as a solvent. One chloride atom again you take from outer side to inside sphere, which will act as a ligand now. Now, what is chloride present in the coordination sphere never behaves as radical. But what is present outside the sphere as a chloride ion, which will give the chloride test by treating with silver nitrate, it gives white cloudy precipitate. Now the color is green color, that is dihydrate. So what is the name? Tetra aqua dichlorido chloride. That means chromium how much? +3. Dichlorido chromium 3 Roman numeral, that is chloride. It is, what is this? Tetra aqua dichlorido chromium 3 chloride. The color is green. This is dihydrate. One is anhydrous, monohydrate, dihydrate. Remember, here due to water of crystallization and different number, that is why color also different. Anhydrous violet, monohydrate blue green, dihydrate that is green color. You know also in organic chemistry copper sulfate. Copper sulfate is having water of crystallization 5 water. When there is 5 water molecules of crystallization, the color is blue. On heating, 5 molecules of water evaporated and becomes anhydrous. When it is anhydrous, the color is white, the colorless. That means here copper sulfate with 5 molecules of water crystallization, it gives color, blue color. On heating, water molecule evaporated, there is no water, that is called anhydrous, and it is color is white color, that is colorless. Similarly, here also one is no water, fill 1 water molecule, 2 water molecule present, that is why the colors are different. Now we will see other examples of the solvate isomerism. Here we will observe the second example, that is tetraamine. That means 4 ammonia molecules surrounded by cobalt, central metal ion, and water aqua Cl minus chlorido. That means coordinate number is 6. So 6 ligands are attached to the cobalt, that is why, and outer side sphere bromide is there. So what is the name? Tetraamine aqua chlorido cobalt 3 bromide. Is it clear? That means it can give the bromide test. When you see solvate isomer, 1 water molecule is inside, so it can go outer side as a water molecule solvent, and that 1 bromide can come to inside the coordination sphere and acts as a ligand. So what is the name? Tetraamine B and C. B will first alphabetically, bromido, chlorido, cobalt 3. Again tetraamine, bromido, chlorido, cobalt 3 bromide, monohydrate. That means here water molecule, 1 water molecule, that is gone to outer side sphere and act as a monohydrate. So here you can say in conclusion, isomerism, the 2 types, structural and stereo. Stereo have not started till now. In structural, linkage, coordination, ionization and solvate isomerism are there. Again see, linkage, coordination isomerism, ionization isomerism, solvate isomerism are there. One by one, in one video I have explained one linkage isomerism, in one video I have explained. Similarly, each video contains one isomerism. And here stereo means there are 2 types, one is geometrical, other one is optical. Now in geometrical also we will read, so one is cis and trans, like this. Optical also we will read. Now my question is, give an example of ionization isomerism. Sometimes the question may ask, give an example of ionization isomerism. You think yourself, you may take chloride as anion, that is counter ion, and you take bromide, you take sulfate, like this you take this one, and inside ion you can replace, so that the acid radical test and outer side can be possible. Coordination number is fixed or not? Yes, coordination number is fixed because it is the polyhedron, that it means I will come to that one, hybridization. Coordination number 6, why? The polyhedron fixed, why? Why the structure is fixed? Since structure is fixed, since structure depends on hybridization, that is why structure fixed, From this structure you can say that coordination number also fixed, that means ligand number also fixed, the attachment of the ligands to the central atom also fixed, or you can say donor atom is fixed. So that is why here I have already finished all the type of isomerism belong to structural isomerism. In coming video I will explain geometrical isomerism and optical isomerism. When you will come to geometrical isomerism, at the time also I have to clear what is hybridization in coordination compound. Hope you will like and subscribe my channel, B.L.DASH short and sweet in chemistry. Thanks for watching my video. Thanks again to all.